All right, we've made it to lesson 5 in chapter 2. We're comparing and ordering fractions, decimals, and percents. But before we do this, let's make sure that on your vocab sheet you have the definition for least common denominator, and also you have written when it's important to have two fractions with a least common denominator. If you do not have these two on your vocab page, I need you to pause the video right now, get this written in, and then play it to do the lesson. Hello, hello. It is time for lesson 5. We are in our math book on page 129. The learning objective for lesson 5 is I can compare and order fractions, decimals, and percents. All right, the key to this chapter is going to be the vocab word, least common denominator. So the least common denominator, remember, is the least common multiple of the denominators of two or more fractions. And the reason why we care about least common denominators is because when we have a least common denominator, then we can compare the numerators in a fraction. And this chapter is all about comparing and ordering fractions, and then decimals and percents. So let's take a look down at the bottom at this real world link. Ernest is baking, but he wants to use only one measuring cup. He needs a half a cup of sugar and 3/4 cup of flour. So what is the least common multiple of those denominators? Oh, pencil fail. All right, we have a 2 and a 4. Now, what's the least common denominator is just like asking what is the least common multiple. So when you have 2 and 4, oh, geez Louise, when you have 2 and you have 4 and you're listing the multiples, 2, 4, 6, 8, oh, wait, 4 is in both, and that's the least common one. So it must be 4. All right, so the question is, what size measuring cup should he use? Well, if he can only use one measuring cup, he's going to want to use the one with the fourths. Why is that? How many would he have to use if he had a 1/4 cup? How many would he have to use to get a half cup? So with a half cup, 2 times 2 is 4. So if he put 2 1/4 cups, he could get a half a cup of sugar. And then how many would he need? How many 1/4 cups would he need for flour? He would need 3. So Ernest can use a 1/4 cup to get a half, and he can use a 1/4 cup to get 3/4. That's the cup he needs. Cool. Good luck, Ernest. All right, let's get down to business. Here are the 2 things that you're going to do in this chapter. On page 130, you're just going to focus on comparing and ordering fractions. Then we're going to compare, order fractions, decimals, and percents. So we're going to figure out, okay, what's the best way to do that? If we know how to compare and order fractions, how do we add in decimals and percents to the mix? So those are our 2 things we're going to focus on. So look. Here are the 3 steps to compare and order fractions. This is your big, important thing. The 3 steps to compare and order fractions are, to compare and order fractions, you can follow these steps. Number 1, find the least common denominator of the fractions. That is the least common multiple of the denominators. So number 1, you want to find the least common denominator of the fractions. Number 2, you want to write an equivalent fraction for each fraction using the least common denominator. That's what we did on the other page. When you look back here, once we found the least common multiple or the least common denominator, we were able to write an equivalent fraction so we could compare 2/4 and 3/4, which, by the way, which one's bigger? 3/4. There are 3 here, there are only 2. So once we have common denominators, then we knew we could use that 1/4 cup, and we can say this one's larger than that one. So 1, find the least common denominator. 2, write an equivalent fraction for each fraction. And then 3, you can compare the numerators, which is what we just did there. We said that 3/4 is more than 2/4. So that's what we're going to do. Let's do some examples. Hey, remember back in the day when you talked about less than, greater than, or equal to symbols? And you talked about the alligator and it eats the bigger number. Oh man, all those memories of first grade coming right back. So we're going to write one of those little symbols in here, and we're going to have the alligator eat the greater number. So let's follow step 1. Let's see what they did. Following step 1, you have to find the least common multiple of denominators. Hey, remember this? Remember how you can list out multiples, or you can do the tree? This is like a tree situation. Let's do that for 8 and 12. If you were listing out multiples for 8 and 12, 8, 16. So you're just always adding 8 more, 24, 32, 12. 12 and 12 is 24. Oh, look, we already found a common one. So that was the listing method, but then there was also that factor tree method. So let me just break that one down for you again. You take 8 and you take 12. Is that the other one? 8 and 12. And you break it down here. So you can do 2 times 4. We're trying to find the prime factors. 2 times 2. So here are our prime factors. And then with 12, let's do 3 times 4. There it's prime. 2 times 2. Prime, prime. Remember that? Then you had to circle the common ones. They both have 2 in common. You only use those once. So 2 and 2. And then you use the leftovers. Times 2 times 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So that gives you the same answer. So our least common denominator here was 24. Now step 2, after you find the least common denominator, you write an equivalent fraction. So 5/8 equals how many 24ths? 8 times 3, 5 times 3 gives you 15 24ths. 7/12 is how many 24ths? 12 times 2, 7 times 2. So now, which one is greater? We can compare step 3, compare the numerators. 15 is greater than 14. Therefore, 5/8 is greater than 7/12. So up here, the alligator eats the 5/8. See that? 5/8 is greater than 7/12. All right, let's do these problems together. 2/3 and 4/9. Now, what is our multiple here? 3, 6, 9. Ooh, look. 3 can go into 9. So let's have a denominator of 9. So we can compare 4/9 to how many ninths over here. We have to write an equivalent fraction. 2/3 is how many ninths? 3 times 3 is 9. 2 times 3 is 6. So 2/3, it's like saying 6/9. So what's greater? 6/9 or 4/9? Compare numerators. 6 is greater. Eat the bigger one. All right, here's 8 and 12 again. Hey, we already know the least common multiple is 24. So in 8 and 12, we need to get these in equivalent fractions to equal 24. Let's do 5/12 over here. 5/12 equals how many 24ths? You multiply by 2. 12 times 2, 5 times 2. So that's 10 24ths on this side. How many 24ths is 7/8? Write an equivalent fraction. All right, 8 times 3, 7 times 3. You've got 21 24ths. Now, they have the least common denominator here. They're the same, so let's compare numerators. 21 is greater than 10. Eat the 7/8, alligator. All right, let's attack this one. The first thing we have to do up here is you have to find the least common denominator. So 6 and 18. 6, 12, 18. Can't 6 go into 18? Yes, it can. So let's keep this as 5/18 and let's convert 1/6 to an equivalent fraction with a denominator of 18. 6 times 3 is 18. 1 times 3 is 3. So this is like 3/18. Now compare numerators. 3 and 5. The 5 is greater. Eat the 5/18, alligator. All right, cool. So that's when you're comparing two different fractions. The other thing that you're going to be asked to do is put fractions in order. So we're doing the same thing, we're just ordering it from least to greatest or greatest to least. So it says order the fractions 1/2, 9/14, 3/4, and 5/7 from least to greatest. Rewrite each fraction using the least common denominator. And it's saying our least common denominator is 28. Hey, I've got a little tip. When you find the greatest number, you say, hey, can these numbers go into 14? 2 times 7. Oh, 4 doesn't go into 14. So let's do a multiple of 14. What about 28? 2 can go into 28, right? 2 times 14. 14 times 2. 4 times 7. And 7 times 4. So 28 can work here. So let's see what they did. They set up equivalent fractions. 2 times 14, 1 times 14 for the 1/2. They set up an equivalent fraction here by multiplying by 2, an equivalent fraction times 7, an equivalent fraction by times 4. Now we have all of these 14, 28, 18, 21, and 20. Comparing those numerators, you can put it in order. The least one is this one, so 1/2 is the least. 14, then 18, so 9/14, then 20, so 5/7, and the greatest one is 21/28, that 3/4. So let's do this one together. We're going to order these 1/2, 5/6, 2/3, and 3/5 fractions from least to greatest. Let's do this first step. Find the least common multiple, least common denominator. Look at the biggest one. 2 can go into 6, 3 can go into 6, 5 can't go into 6. Let's try 12. Wait, 5 can't go into 12. What's another multiple of 6? 6, 12, 18. 5 can't go into 18 still. 24. Can 5 go into 24? Nope. 30. Can 5 go into 30? Yes. Can 3 go into 30? 3 times 10. Can 2 go into 30? 2 times 15. 30 is the one we want. So let's set up equivalent fractions. 1/2 is how many 30ths? 2 times 15. 1 times 15. So 15 30ths. 5/6 is how many 30ths? 6 times 5. 5 times 5. 25. 2/3 is how many 30ths? 3 times 10, 2 times 10. And then 3/5 is how many 30ths? 5 times 6, 3 times 6. Oh, sorry, 18. So 18, 20, 25, and 15. Look at those numerators now that the denominators are the same. The smallest one is here. So 1/2 is the least. All right, 15 and then 18. So 3/5 is next. All right, then 20. So 2/3. And then 25 is the greatest. So 5/6. So cool, we have gone from least to greatest. So just wrap up, no matter what we're doing, if we're just comparing two or if we're ordering more than two, you always follow the 3 steps. Find the least common denominator, write equivalent fractions for each one using the least common denominator, and then compare the numerators. Now that we know this trick, how do we add fractions, or how do we add decimals and percents into our situation here? We know how to deal with fractions. How do we put in decimals and percents? You'd think maybe just make them all fractions, but actually it might be easier to compare fractions, decimals, and percents when they're all written as decimals. So this is the trick that we're going to use. We are going to try to write them all as decimals. It may be easier to compare fractions, decimals, and percents when they're all written as decimals. All right, let's see why. First of all, notice here we're talking about fifths, and here we're talking about eighths. So let's go back in time to thinking about how do we convert a fraction to a decimal. All right, there were two ways to do it. One, you can get the denominator as tenths, hundredths, or thousandths. Or two, you might have to use long division and divide the numerator by the denominator. Well, in this top section here, when you have fifths, you can easily get the denominator to 10, 100, or 1,000. So let's go to tenths. Let's do this right here. 1/5. 1/5 is how many tenths? Write an equivalent fraction. 5 times 2, 1 times 2 is 2 tenths. Now, how do you write 2 tenths as a decimal? You put the 2 in the tenths place, 0.2. See how this right here, 0.2, matches up with this. Now, how did they get 20%? We could do that a couple ways. You could take 2 tenths and you could turn that into hundredths, because percent's magic number is you want 100 in the denominator. So that's 10 times 10 and 2 times 10. 2 times 10 is 20. 20 100ths is 20%. So there you go. 1/5 is 2 tenths is 20%. Some of you like to move the decimal. 0.2, when you're turning it into a percent, you times it by 100, so you're moving it 2 to the right. 1, 2. So there's your 20%. Now, man, sorry about that. So 1/5 becomes 2/5 when you double it, 3/5 when you triple it, 4/5 when you quadruple it. So we don't need to show I'm not going to go through each one of these, but this is double this one, triple this one, and quadruple this one. All right, let's look at 1/8. Now here's the problem. 1/8 you cannot convert easily to a denominator of 10, 100, or 1,000. So when you get the eighths, that's one of the ones that you do the long division with. So let's review what that long division looks like. You divide the numerator by the denominator, even though it feels wrong, right? It feels weird putting the 1 in here, but that's what we have to do. 8 can't go into 1, so that's why you start adding this decimal situation. 8 can go into 10. Look at that. 8 can go into 10 once. 8 times 1 is 8. 10 take away 8 is 2. Bring down the 0. 20. 8 can go into 20 twice. 8 times 2 is 16. Bring down another 0. Look at perfect. 8 can go into 45 times. 8 times 5 is 40. No remainder. So that's that decimal, 0.125. Now, the easiest way to convert this to a percent is to do the move the decimal method. Times it by 100. 0.125. Take this out. Move it over twice, and you have 12.5%. So we want to try to incorporate all the methods we learned and use the easiest method when you can. Be able to decide what the easiest method is. So, again, 1/8 is this. 3/8 is 3 times this. Oh, look at here. We have thirds here. Thirds are the same thing where you have to do that long division because thirds can't easily go into 10, 100, and 1,000. So when you're dealing with thirds, you have to do that again, 1 divided by 3 to get your decimal, to figure out what 1/3 is as a decimal. So that's where you add this decimal here. 3 can go into 10 3 times. 3 times 3 is 9. Subtract. You got 10 here. By the way, what's going to happen is this just keeps repeating and you're just going to keep getting 10. That's what this little symbol is. It's that 3 is repeating, 0.333333333. When you move the decimal over to get the percent, 0.3 times 100, you're taking this out, move it 1, 2. But, by the way, remember this is a 3 repeating. So that's why it says 33.3%, because that 3 repeats. Now, 2/3 is just taking this and doubling it. So that's our little mini review of how to go from fractions to decimals to percents. Because down here, we're going to want to get percents and fractions to a decimal. That is our tip. Once we get them as decimals, then we can compare which is larger and which is smaller. Look at how easy it is to compare. 0.2, 0.4, 0.6, 0.8. Look at this. 2/10 is way smaller than 8/10. 2/10 is smaller than 4/10. 2/10 is less than 6/10. Compare this. 125 hundredths. This is like, 125 thousandths compared to 2/10. Well, that's like 200 thousandths. So 125 thousandths, 200 thousandths, this is more. So this is going to be more than this. You can see that in the percents too. 20% is more than 12.5%. Here we go. We're going to try this. We're going to look at an example first. So if you have the fraction 3/4 and you have the decimal 7/10, you're trying to figure out which one is greater. We're going to try the method of turning both into decimals. All right? And some of you might be sitting here like, oh, you could turn that into 7/10. Then if you had 7/10, you'd have to get least common multiple there, which you totally could do that too. You could find the least common multiple, which I believe would be 40, and then you could write equivalent fractions and you can compare them. But later on, it's going to be easier to compare decimals, so that's why I'm showing you how to compare decimals right now. So this is written out, 3/4 and 7/10. Write 3/4 as a decimal. All right, so you know what? We're going to have to do that. 3/4 as a decimal. Let's get it to a hundredths. 4 times 25, 3 times 25 is 75 hundredths. All right, so 75 hundredths written as a decimal, 75 hundredths. So this right here shows you that's 75 hundredths. 7/10, if you add that 0 there, which you can always add zeros, by the way, remember. What is greater, 75 hundredths or 70 hundredths? So think of this as 75 hundredths and this as 70 hundredths. The 75 is greater. 75 is greater than 70. 75 hundredths is greater than 70 hundredths. Or you can think of it as 75% is greater than 70%. They all intermix, fractions, decimals, percents. Look at this number line because this is going to give you a visual. Here's a half, or 5/10, 6/10, 7/10, 8/10, 9/10 in a whole. See how 0.75 is greater than 0.7. That's just a visual to remember, especially if you're a visual person and you need to see it. So our answer here is 3/4, because that was 75 hundredths, is greater than 7/10. So here is the answer. All right, now let's look at with percents and fractions. And let's see how it's easier to get it to a decimal. So 85%, that is just the same thing as 85 over 100, which is 85 hundredths. So you write it as a decimal. 0.85 is 85 hundredths. 7/8. Now, all this work we did earlier up here was 1/8. So let's do the 7/8 work over here. You can't get 8 into 10, 100, or 1,000, so we have to do that division. 7 divided by 8. All right, how many times does 8 go into 70? What's 8 times 8? 64. All right, so put that here, 64. Take away, you get 6. Bring down another, oh, we forgot to put that decimal there, didn't we? Bring down another 0. How many times does 8 go into 60? 7, because 8 times 7 is 56. All right, take that away. 4. Bring down another 0. 40. Oh, there it is. There's our last one, because it's 40 now. So here is our decimal. That's where they got this from. So now we have 85 hundredths. We're comparing it to 875 thousandths. That's why we add a 0 here. This annexes 0 to 0.85. we're adding that, so it's kind of like comparing 850 thousandths to 875 thousandths. 850 is less than 875 thousandths. And if you look at that on a number line, 0.85, 0.86, 0.87, 0.88, 0.875 is here. This is less than this. So that's the visual way to look at it too. So our answer is that 875 thousandths is greater than 850 thousandths. So this 7/8 is greater than 85%. All right, this seems like a lot because it kind of is. We have to use everything we learned in lessons 1 through 4 to change all of these fractions and percents and decimals into each other. So we're going to do these problems together. All right, here we go. We can do it. It's not as bad as it looks. All right, we have 2/3 and we have 6/10, and we're trying to write these as decimals and then compare them. So we need to turn 2/3 into a decimal. So I'm going to do that right over here. We can't change 3 to a 10 or 100 or 1,000 easily. We have to do that long division. 2 divided by 3. Add that decimal. Here we go. 3 can go into 20. Well, 3 times 6 is 18. All right, that gives you 2 more. There's another 20. Uh-oh, it's happening again. That repeater thing. Remember where it keeps repeating? Just like up here where it repeated the 3. It kept happening over and over again. So that's what's going to happen here. You're going to get 0.6 repeating. So this is just like saying 0.666, repeating, repeating, repeating. Let's add a couple zeros here. So let's compare that. 600 thousandths and 666 thousandths. 666 is greater than 600. So there's your answer. All right, 0.7, so 7/10, comparing that to 8/11. All right, so let's get this 8/11 into decimal form. Well, here's the problem. 11 can't easily go into 10, 100, or 1,000, so we have to do that long division again. It's a good thing we practiced this. 8 divided by 11. Add those decimals. 11 going into 80. Well, 7 times 11 is 77. So there's your subtraction. You get 3. Bring down a 0. 11 can go into 30. How many times does 11 go into 30? 2. 2 times 11, 22. All right. Now, this is going to bring down an 8, and I'm getting really squished in here. It's going to bring down an 80. This is going to keep going. Let's see if we can pause for a minute, because look, 0.7, and now we know that this is going to be 0.72 something. This is like 0.70. Which one is greater, 72 hundredths or 70 hundredths? 72 is greater. All right, now we have 1/5 compared to 2/10. So let's get 1/5 in fraction form. Oh, this is going to be way easier because 1/5 can get turned into tenths. Remember, 1/5 can become tenths really easy if you multiply by 2. So that gives you 2/10. Yay, what's the decimal for 2/10? 0.2. So this is like 0.2 compared to 0.2. 2/10 and 2/10 is equal. Let's do this one. 42% compared to 44 hundredths. How do we get 42%? Oh, you guys, remember how easy this is when you move the decimal? 42% to a decimal, you move it 2 to the left because you're dividing it and making it smaller. So take this out, move it 2 to the left. 0.42 and 0.44. 44 hundredths is more than 42 hundredths. That one, oh, you guys, percents are a little bit happier. By the way, you could have also done this as 42 over 100 and written that as this. So if you like that method, let's use that method here. 7% is like 7 hundredths. 7 hundredths is written 0.07. So the 7 is in the hundredths. So 7% is like saying 0.07, 7 hundredths. This is 7 tenths. All right, how could we write 7 tenths as a decimal? Say it, 7 tenths, and then write it, 0.7. The 7's in the tenths position. So what is more? Look at add a 0. 70 hundredths or 7 hundredths? 70 hundredths is way more than 7 hundredths. Last one. Oh, you guys, look. We have numbers that are greater, percents greater than 100. Ooh, this is like lesson 4. So 6.5 is in decimal form. Let's get this percent into decimal form. Well, the easiest way to do it is to move the decimal 2 to the left. 1, 2. That's 6.5. Oh, look at 6.5 and 6.5. That's equal. All right. Ooh, I hear children coming downstairs. Did you hear that? My kids might be coming down. You might get to see them. Or you can think of that as this, go into this whole 650 hundredths. Ah, you know what? Use the move the decimal method. All right. One more little example on page 132. Okay, here's page 132. The table shows the school carnival attendance. Which grade has the greatest part of the class attending the carnival? All right, sorry. All right, so grade 6 has 5/8 attendance. 5 out of 8 kids come. Grade 7 has half the kids coming, 5 tenths. And grade 8, that was grade 7, I think I said that wrong. Grade 8 has 58.3% of the people coming. So, order the numbers. Which grade has the greatest? Order the numbers from least to greatest. Express each number as a decimal with the same number of places. So, by the way, did we do 5/8 over here? Oh, we never did. Okay, so they've already done this for us. 5/8. Remember, you have to do long division for that, by the way. That's how they set that up. Okay, 5/8 became 0.625, 625 thousandths. 1/2, if you add 2 zeros to it, or 5 tenths, sorry, is 500 thousandths. And then moving the decimal here over 2 is 583. Seeing this visual on a number line, or just comparing 625, 500, and 583, the greatest one is 625 thousandths, which is 5/8. So from least to greatest, this is the least one, this is in the middle, this is the greatest one. So grade 6 has the greatest part of class attending the carnival. Let's do this story problem together. Hiroshi found that 3/5 of his class prefers vanilla ice cream, 26% prefers chocolate, and 14 hundredths prefers strawberry. Which kind of ice cream do students prefer the least this time is what we're looking at. Let's get them all to a decimal like this. So we have strawberry as 0.14. All right, now let's turn 3/5 into a decimal. Fifths can easily go into tenths, so let's just go that way, that easy route. We don't have to divide unless you like dividing. 3 times 2 is 6. So 6 tenths is written like this. And let's add a 0 so we're comparing hundredths. All right, so that's 3/5. 3/5 is vanilla. This one is strawberry. Now, chocolate, 26%. 26% prefer chocolate. That's like 26 hundredths, which is written like this. Chocolate is 26 hundredths. You could have also moved the decimal. 1, 2, 0.26. So which one is the least? 60, 14, or 26 hundredths? Strawberry. All right, We did all the examples. Now, we're going to do guided practice next. We're on page 132. Get ready for guided practice. You're going to try it, and then you're going to check your work with me. All right, here we go. So for the guided practice on page 132, the problems that we're going to be doing are 1, 2, and 3. So what I want you to do is I want you to try number 1. It says order the fractions 4/5, 1/2, 9/10, and 3/4 from least to greatest. So all we're dealing with is fractions. We get to go back to Happy World here where you find least common denominator, write equivalent fractions, and compare numerators. So go ahead and do that. Find the least common multiple, least common denominator, do the equivalent fraction, compare numerators, and you're ordering from least to greatest. Show your work down here, and then check your work with me. All right, here's how I would do that. I'd look at these numbers. I'd find the biggest one to find the least common multiple. 10. Can 5 go into 10? Yes. Can 2 go into 10? Yes. 4 can't go into 10. So now I'm going to try the next multiple, 20. 5 can go into 20. 2 can go into 20. Can 4 go into 20? Yes. 4 times 5. So 20 is the number that I want to use here in my denominator. Let's set up equivalent fractions. 4/5 equals how many 20ths? Times 4 is 16. All right, 1/2 is how many 20ths? Times 10 is 10. 9/10 is how many 20ths? Times 2, 18. And 3/4 is how many 20ths? Times 5, 15. Compare numerators. We're ordering from least to greatest. Least is 10/20ths, so that's 1/2. 10, and then 15, that's 3/4. And 16, 4/5. And then the 18 was the 9/10. So there's your order. All right, what's problem 2 going to bring us? Cora spends 2/3 of her free time blogging on the internet. Leah spends 60% of her free time blogging on the internet. Who spends more of her free time blogging? Well, our trick was to try to compare decimals. So that's what we're going to do. Remember, turn 2/3 into a decimal, and I believe you're going to have to do long division because 3 can't turn into a 10, 100, or 1,000. And then turn 60% into a decimal. All right, do that and then play and see how I did it. All right, so 2/3. I've got to set that up. 2 divided by 3. I put in my little decimal info. And 3 times 6, 18. 2, bring down the 0. This is happening again where you're getting a repeated 3 times 6. Then you get 18, and then you get, so this is that repeated 0.666. 60%. 60% is just like 60 100ths. 60 100ths, you write that, 60 hundredths is 0.60, right? 60 hundredths. Or you could have just moved the decimal 2 to the left and got that. So we're comparing 66 hundredths to 60 hundredths. 66 is more than this, and this is asking who spends more of her time. So who was the 2/3? Cora. Cora spends more of her time blogging. Oh, Cora. All right, last one. The table shows the wins for some middle school football teams. Which team has the greatest fraction of wins? Ooh. Percent, fraction, and then a decimal. Eagles, Wolves, or Mustangs? Let's convert them all to decimals like the Mustangs. So the Wolves. All right, Wolves, 9/10. If you say that out loud, 9/10, then you go ahead and write it as a decimal, 9/10. Let's add a 0 so it's in the hundredths, just like the Mustangs. All right, 95%. If you have the decimal here and you move it 2 to the left, that gives you 0.95. So comparing, we want to know which team has the greatest fraction of wins, 95 hundredths, 90 hundredths, or 89. The Eagles has the most. Yay, Eagles. All right, guided practice is done. Next step is going to be independent practice on the next page. All right, here is our independent practice for lesson 5 in chapter 2. We are on page 133. We are going to do a couple right here where we compare fractions. So do number 1 and 2, circle number 1 and 2. And then in number 8, this one, right? Actually, hold on. I said that wrong. I want you to do one where you compare. Oh, no, I did say it right. Sorry. Yes, do number 2. And then I want you to do number 8 right here. And on number 8, you have a fraction, you have a decimal, and you have a percent that you need to get all to decimal form. So 1, 2, and 8. Go ahead and stop the video. Do all 3 of those for your independent practice. All right, when you have the independent practice done, I'd like you to check your work here with this page 133. Number 1, we had to find the least common multiple, which was 15. Made equivalent fractions with the denominators of 15. 5/15 was less than 9/15, so 1/3 was less than 3/5. So there's our answer there. Here, to show your work, you have to show the equivalent fractions. 12 is our least common multiple, or I'm sorry, 24 is, oh, it should have been 12. Huh? I took this even a step harder. You totally could have just done 1/2 is how many 12ths? So you probably did 6/12 versus 7/12. Either way, the 7/12 is greater than the 1/2, which is 6/12. All right, this last one, here's how I showed my work. I knew I had to get them all into decimals, so I had 22 hundredths here. I turned 1/5 into 2/10, equivalent fractions. I wrote it like that. Now 2/10, when you add a 0, is 20 hundredths. And then for 19%, you can either move the decimal or you can set it up as a rate over 100. You get 0.19, so 19 hundredths. They wanted to know which one is the least. So the bar with 19% is the one with the least amount of calories from fat. All right, independent practice is done. Next step is your reflection. All right, it's time for the Chapter 2, Lesson 5 reflection. Let's just go through what you need to do. Remember, your learning objective is I can compare and order fractions, decimals, and percents. There are 2 parts. 1, when I have fractions with different denominators, I can compare and order them by following these steps. And here's my work to show which fraction is greater, 3/5 or 2/3. You'll write the little alligator sign in here, but make sure that you show your work. Now, if you don't quite remember all the steps, remember on page 130 at the top, it went through those 3 steps with you. And then number 2, when comparing fractions, decimals, and percents, it may be easier to write them all as what? What did we want to change them all into to compare them? Here's my work to order the quantities 35%, 3/8, and 37 hundredths from least to greatest. So you're going to put the least one here, middle, and then the greatest one here. Now, hey, if you don't remember this, what you want to turn them into, that was page 131 at the top. And also, I'm noticing here when you have this denominator of 3 and this denominator of 8, that you're going to need to remember that long division method, since you can't write equivalent fractions with tenths, hundredths, or thousandths, 10, 100, or 1,000 in the denominator. So remember all those times I went through long division with you on these pages. All right, go back and look at that in your book and see how to do it if you don't remember how. All right. do the reflection and then the learning objective check-in.